Today's project is wiring lockers on this thing. So we've got a new Eaton locker, E-Locker, in both the front and rear of this, replacing, well, with the new axle, intended to replace the factory TJ air-driven locker. The way the original system was set up, and looking at what we've got from the factory service manual on connector pinouts and wiring, they used a relay in the front box to drive a 12-volt low-pressure air pump separate for front and rear. So they had two pumps. What we think we can do is basically take that circuit and run it directly into the new locker to activate the locker. So instead of running a pump, running that electric motor, it'll run the locker directly. There is also a locker indicator switch that causes the light on the dash to come on that needs to be dealt with, where they had a switch that was actually in the pumpkin to detect the position of the locker. That will require a little bit more thought, whether we actually have to have that as a switch that opens and closes as expected, or whether we can just maybe short it out and have it be good. Stuff on the forums seems to indicate that other people have done this, and at least some of them seem to suggest they could just short that sensor and it's all good. One step at a time, we've got to verify that everything works the way we expect, the pinouts, the connectors are what we expect, and where we go. One thing that is very convenient on this setup is they took all the factory wiring for this right to the back of the transfer case. That's where those factory pumps lived, and that's also where they put the pigtail that went out to each of the axles for those locker sensors. So all of the factory wiring terminates right behind the transfer case. Sort of convenient for the purposes of running new wiring out to the axles, because we can just come down the control arms and should all work.
So a useful thing to have is a copy of the factory service manual. It gives us detailed pinouts of each of the connectors. You can see front locker indicator, front locker pump, and what each pin, the wire color, what it's for, what it does, and for front and rear. And so we're going to use that as our starting point to figure out exactly how to wire all this up. So the work we've done so far with this wiring harness, it came from the factory. We rerouted the fuel pump wiring, fuel level sender, everything. That's all split out from this harness. They were grouped together all the way down.
So at this point, what we really want to do, we've got the pinouts from the factory, and the idea is verify physically that we have the right signals on each of the connectors for what we're expecting. So the idea here is verify proper function, and then we'll start modifying the wiring. So I think the next step is I will crawl up in the cab so we can put it into gear, command the lockers, and verify what happens here.
Smile on.
Ignition is on. We're in 4-wheel low. The rear locker is asking to be engaged, but the light is flashing, so it's looking for the sensor.
Right. And so what I've done is I've looked at the rear locker pump. It's the 3-pin connector with the white trace wire, which is the output and the ground. And so I found that one. Here's the red and white wire. I've got my pins in. And sure enough, almost 12 volts, which is battery voltage. I think our batteries might be a little low, but that's fine. So this is, in fact, the right connector. And so I'm gonna have our nice tags. Get that down a little bit. Okay. And now I'm looking for the rear locker indicator switch, which is what the sensor plugs into, and that's the violet and light blue wire. And yep, that's violet and light blue. So I'm going to do this. And that. And then our jumper. Yeah. And that should indicate locked.
I now see a solid rear lock indicator here.
Okay. So we have.
Try canceling it. So now I've canceled the lock. I have a flashing rear lock indicator.
Okay.
And the rear lock indicator is now off.
Right, and that coincides with me disconnecting the pins. What we determined is that when you've engaged the locker, the sensor needs to connect the two pins together. When you disengage the locker, the computer expects that it will open, and so otherwise the dash light will keep flashing at you. And so what we're going to have to do is incorporate a relay that's triggered by the rear locker driving wire that will connect the two wires together, and then when you turn off the locker, the relay will open and it will tell the computer that the locker is turned off. And so we've got the rear locker sensor and drive switch figured out, and should be the same. And we're just, to be thorough, we're just going to verify that the front locker behaves exactly the same way. So.
Okay, so that's commanding a rear lock.
Okay.
Now commanding a front lock as well.
Okay. And yep. So we're getting good battery voltage. So so we've cut this wire. So jumping that pin won't make a difference. But what we can do is use the ground pin from one of the others, because they all come together anyway. And so front locker should show engaged.
Front locker now shows engaged.
Okay. And so that behavior is exactly what we expect. All right. So we have figured out the behavior of all of the computer functions.
Okay, so we've now confirmed the behavior and function of all of our connectors, our wires. The next question is, how do we want to manage the wiring, the actual physical wiring of this? So I'm really not sure I want to put a relay down here if we can help it. I'd rather have it up under the hood where we can.
That's easy enough to do.
Yeah, so I think what we're going to end up doing is we need we'll want a connector here. This is just a really convenient place to run a wire down a control arm to the axle, or to run a control arm, or run a wire down a control arm to the other axle for the actual lockers.
Mm-hmm.
But I think we're going to want to take our signals that are related to the locker indicators up under the hood to a relay box up there.
Yeah.
So that's, as we think about our wiring, which signals do we need to put into a bundle going that way versus which ones into bundles going out to the two axles. So looking at how our wiring behaves, the number of circuits, number of wires we have to deal with, before starting to cut wires, let's figure out what we've got for parts and how we're going to wire this together to have it work. What we know is we've got the connectors that match the Eaton E-Lockers. This is a Delphi style connector. You can buy them online, various places, Amazon, others. We know we've actually got 5 distinct wires coming out of the factory harness. It's a ground, and then a
2 locker triggers, 2 locker sensors.
2 locker triggers, so a total of 5 there. We're going to need to run some kind of a relay in order to cause the locker sensors to behave the way we need them to. So we have a requirement for some relays. We know we're going to add some additional relays to this vehicle in the future for lights, compressors, other things. So we'll be proactive about this. This is a relay box I picked up off of Amazon for like $25 that came fully loaded with 6 Bosch style relays and fuses and
in a nice
in a nice weatherproof box. So
yeah.
Locating that up under the hood. So with that,
and yes, lockers before lights.
So kind of with that, I think what we're going to do is we'll terminate all of the factory connectors in this 5-pin weather pack. That'll break us into our new harness. We'll take the ground that's in that factory connector, run that out to the front and rear lockers. We'll take the 2 locker signals and run them to the locker through these connectors as appropriate. We'll also need to run those up to the relay box. And then we'll take the 2 wires that are the sensors, run those up to the relay box as well. I think just as a convenience, we'll put the additional connector in there between this harness and the relay box. That allows us to take this harness out of the vehicle if for some reason we needed to, or adapt it going forward. But then we'll just take it'll be the locker trigger and the locker sensor, those 4 wires up into this connector, into the relay box. And basically what we're going to do is just take the relays to a chassis ground at that point.
Right. That
will complete the circuit to close the relay, as well as allow us to short the trigger to ground.
Yeah, and so the locker triggers will be the relay triggers, and I'm not remembering all my numbers. We will connect the locker trigger to pin 85. Pin 86 will be ground. Pin 87 will be the locker sensor. And 30 will go to ground. And 87A, because this is a dual throw relay, which is overkill, but it works, 87A will not be used. And so what will happen is when the locker turns on, that will flip the switch to 87 to connect the 2 and take the sensor signal and connect it to ground. And as soon as you turn off the locker, the relay will turn off, and that will turn off the sensor, and your lights should work correctly.
Right. I mean, if we simply ignored the locker sensors, you would still get the light coming on the dash, but it'll sit there and flash at you, which
which is annoying.
Can become very annoying. There's an aspect of a flashing light which is intended as a pay attention to me, which for a locker, some might consider to be a good thing because you want to turn the locker off as quickly as you can after you've activated it. But it, we don't want to cause seizures to the driver or anything like that from having a bunch of flashing lights on the dash.
The driver says thank you.
Yes, keep April happy. When you're using these WeatherPack, MetroPack, Delphi connectors, it is a good idea, and we will post a link to some of these tools. A very good crimping tool specifically for the pins makes the job so much easier. And of course, a nice wire stripper. I mean, you can use anything you like, but investing in a good wire stripper if you're going to do a lot of wiring is really worth doing. So, yeah, having the right tools makes the job easier. Speaking further to having all the right tools and everything, I kind of went a little overboard. I am an engineer and I overdo things. I got an entire kit of these WeatherPack. I also have some MetroPack connectors in here and a couple bulkhead connectors. They come with all of the pins that you need to crimp and all the water insulation. I broke down and got a really nice tackle box that lets me keep everything organized. I keep all of my flat 4-pin and 2-pin and everything. I keep them all organized. And so I've got, this is the MetroPack one, and these are the lower amperage capacity MetroPack. We're using the WeatherPack that can handle the 10 amps of a locker. But yeah, so having something like this really helps keep you organized if you go overboard like we do. Similarly, as you start to work with lots of wiring, just having more than red and black wire can make things a lot simpler. Like in today's project, we've got 5 wires going up to a relay box. Having 5 distinct colors makes it much easier to keep everything straight. Your favorite electronics store, Amazon, whatever, can buy this stuff. It is generally better to buy, or cheaper, more economical if you buy it in bulk. Also important, there is automotive grade wiring, which is what you want to use. It has a little more weather tolerance, oil resistance, that sort of thing. It's designed to be used in an automobile.
Manages flexibility and movement better than household wire does.
And we don't have it here, but I have. I bought split loom tubing in bulk, and I'm sure Kenneth has some, but buying it in bulk again, if you're going to do a lot of wiring, economically makes a lot of sense. Everything will end up in a nice loom before this is all said and done. And they do make a tool for inserting wire into split loom. Try it out. And we bought this. We're going to give it a try for the first time today. All right, so we are starting the very tedious process of wiring up all the new wiring that we're going to put in. We're not going to show you every single wire because that's going to take forever, but we do want to show you just the general process for wiring up these Delphi style, MetroPack style connectors. They all kind of crimp basically the same way, even though the ends are slightly different. So first thing you need to do is you need to take your wire, and we have chosen colors to match between the factory wiring and our new wiring. We got it fairly close. You don't need to strip very much off of this, maybe about 1/3 to 1/2 of an inch. And you can see it will sit in this connector. This part will crimp on the wire. This part will crimp around the water insulator. once it's all done. So half the time, well, maybe not half the time, but a lot of times I forget to put the insulator on. That's a very important first step. It's really hard to get it on after. And so you just kind of lay it in there, and with a little practice you get good at holding it exactly where you need it. And again, the right crimping tool makes a big difference. I like to start the crimp just to get it to fit in the jaws. And there are different size crimping dies in here. I like to use the number 3 on this one, and get it and make sure that everything's lined up. And so yeah, you see just a hair of wire sticking out beyond. You don't want much more. And then you squeeze, and it's holding. And do that, bring that around just a little bit, and then bring this around, crimp, and that gets the band around the outside, gets that in place, and this just keeps the water out once the whole thing is assembled. And once that's all crimped, and you hear it click, and there it's in, and it's holding.
So I bought all of the connectors to connect to the locker from this company called Del City, and they do a really nice job of sending out on the invoice exactly what we ordered. And so I ordered some of these Delphi GT150s and some of the GT280s. So the 280 is a higher current, it's a little bit larger connector. We've verified experimentally that the GT150 is the matching connector for the Eaton locker. So then the next question is, which parts represent the terminals that we need to be using for this? We know that we are using the 18 gauge wire. So based on my invoice here, I am looking for the female connector that should be 83819 in the manila envelope at Roy's feet. We are also probably going to be looking for, and this is what happens when you don't have a nice tackle box to keep everything organized. So yeah, we're looking for 83819.
So Kenneth, while he's saying that, why aren't you just using an Eaton wiring harness?
Because the factory Eaton harness does not make the type of connection and behavior that we want. It's a very nice generic harness, but cutting it up to make it work for this application is a lot less convenient than actually building with the right pieces to begin with.